Let's continue talking about what are the advantages of using SD-access networks over traditional networks. I'm going to focus in this time about wireless traffic patterns. Remember that with traditional networks, if you have, for instance, a wireless user that is having, for instance, a voice over IP call with a wired user, this traffic will have to move to the access point. Then using the CAP/WAP tunnel that this access point has with the wireless LAN controller, that traffic will be moved through it in order to reach the wireless LAN controller, and then the wireless LAN controller will have to switch that traffic into the wired network. Then the traffic coming on the opposite direction will go through the wired network. It will have to reach the wireless LAN controller. Then it will be moved through the CAP/WAP tunnel in order to reach the wireless user. This way of moving traffic with traditional networks is known as wireless LAN controller traffic hairpinning, and it has the disadvantage that all the wireless traffic has to go through the wireless LAN controller. Remember that nowadays we have more wireless users, we have new access points that have the ability to move higher data rates. We are connected our new access points through 2.5 gigabit per second and 5 gigabit per second interfaces. So we need more bandwidth nowadays, and you will have to make sure that your wireless LAN controller is able to cope, to accommodate that amount of bandwidth. Otherwise, it can become a bottleneck for your network. Compare that to what happens with SD-access. With SD-access, we have a protocol that is known as Lisp that will help these devices known as edge nodes to locate where these users are. And once they locate them, they will create on the fly a VXLAN tunnel in order to let them communicate with each other. There is also a VXLAN tunnel between the access point and the edge node. So compare that with the traditional network, and you will notice that this traffic pattern is a lot more simpler. So there are other traffics that we have, other traffic patterns that we have in traditional networks. For instance, remember what happens with inter-controller layer 3 roaming. With this type of roaming, a user has moved, and it has moved to a part of your network that no longer can support the original IP address that this user acquired. It has crossed some layer 3 boundary within your network, so the new wireless LAN controller that it has associated with is no longer able to route the original IP address that this user was assigned to when it connected to the network. So it has just associated with a new wireless LAN controller that we will call the foreign wireless LAN controller, and this foreign wireless LAN controller will have to set up tunnel with the original wireless LAN controller that this user was associated with, that we will call the anchor wireless LAN controller. So in order to keep this IP address that this user had originally, the traffic will have to move to the access point, then through the CAP/WAP tunnel to the foreign wireless LAN controller, then to this tunnel that this wireless LAN controller is created, and then after reaching the anchor wireless LAN controller, that traffic can be switched into the wired network. This traffic pattern is quite complex. Compare that with what will happen with SD-access, where VXLAN tunnels are just created on the fly thanks to the Lisp protocol, and after a user moves, then Lisp will help these edge nodes to locate this where this user moved to, and they will create a new VXLAN tunnel to let them communicate with each other. Remember that there is another VXLAN tunnel between the access point and the edge node. So in summary, the SD-access fabric let me have wired and wireless traffic patterns behave similarly. Wireless traffic no longer is hairpin to the wireless LAN controller. This scales better in a way that your wireless LAN controller cannot become a bottleneck for your network, and it provides easier roaming traffic patterns. Remember that Lisp supports mobility natively. That's it.